Hi, welcome back. This is lesson 6 in unit 5 of our Algebra 2 course. This unit is all about quadratic expressions and equations. And in this lesson, we're going to learn about the famous quadratic formula. So in lesson 5, we saw that a lot of quadratic equations cannot be solved by factoring. In those cases, we saw that we could use a process called completing the square. However, if we use completing the square on an equation like ax squared plus bx plus c equals 0, by that I mean we solve this equation here using the process of completing the square. And it's not particularly easy, but I do want to go over it with you at the end of the lesson. So we'll get done with the entire nuts and bolts lesson. We'll go over how this is done. So by using completing the square on this, you can get this equation as a result. And that's kind of how a lot of formulas are in math. We say, okay, look, I solved a bunch of problems and they all seem to be kind of similar procedure. Can I solve the problem with just variables representing the missing numbers? And then there you go, I've got a formula. So this quadratic formula can be used. Let's practice using it. So we're going to use it regardless whether we have to or not for these few practice problems here. So the quadratic formula is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And we need to memorize that formula. So this is a right here. That's b right there. And that's c right there. Okay? So x is negative 4 plus or minus the square root of 4 squared minus 4 times 1 times a negative 32. All over 2 times 1. Okay, so 4 squared is 16. And we really want to be careful about whether this becomes a plus or a minus. It will be one or the other. I have a minus here times a negative. So a minus and one negative makes two negatives total, so it'll be a positive, or in other words, a plus. 4 times 32 is 128 all over 2. Now adding 16 and 128 will give me 144. And now we simplify. Can we take the square root of 144? We can. That's just 12. So negative 4 plus or minus 12 over 2 is what x is. So when you have the situation where it's a perfect square that we get, no radical left over, we're going to split the problem up and do it twice. Once with plus and once with minus to get two complete answers. So this is a negative 4 plus 12 is 8. 8 over 2 is equal to 4. For our x value, and then this is a negative 16 over 2. That's a negative 8. So our solutions, I'll put them right here, are 4 and negative 8. All right, let's take a look at another one. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So for this problem, we have 8 for the opposite b, plus or minus. We're going to be real careful here. If you say negative 8 squared, you just lost the question. You just blew it. It's got to have parentheses around it, so you square both the 8 and the negative. Very important. If you want, you can just leave the negative off, but don't write negative 8 with the squared. Make sure the squared's outside of the negative 8's parentheses. Don't write negative 8 with the square without parentheses. Then a is 1 and c is a negative 2 all over 2 times 1, which is just 2. So x equals 8 plus or minus the square root of 64 plus 8 all over 2. So that's going to be 8 plus or minus the square root of 72. Now 72 is not a perfect square, so we're going to go over here and we're going to do a factor tree. That's 9 and 8, which is 3 and 3, which is 4 and 2, which is 2 and 2. So I got a pair of 2's and a pair of 3's and 1 2 left over in the inside. So it's going to look like this. X equals 8 plus or minus 3 and 2 come out to the outside, giving me a 6, root 2 all over 2. Now, in this situation, you're either going to be done right now, or you can do a little more simplifying. If and only if all three of these numbers are divisible by the same amount, you can reduce. I don't care about that number in the radical because you can't divide it anyway. You can't divide a number in the radical by a number not in the radical. But 8, 6, and 2 can all be divisible by 2, so it's 4 plus or minus 3 root 2 over 1, so just that. So I have 4 plus 3 root 2 and 4 minus 3 root 2. All right, let's go down to the next one. Okay, x is equal to opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. So x equals negative 3 plus or minus the square root of 9. Now I have minus and a negative and a negative. That's 3 negatives, so it's still going to be a minus. And 4 times 1 times 6 is 24. All over negative 2. So I have x equals negative 3 plus or minus the square root of, what is that, negative 15? All right, well, we can't square root a negative. That's not a real number. So we're just going to say no real roots or no real solutions. Okay, I have a few practice problems for you to do. So you can do A, B, C, and then we'll talk about them. All right, let's see how we did. So you should have used the, I'll start more over here. You should use the quadratic formula as the instructions. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 2 squared is 4. I have a minus, but with one negative, that's going to become a positive. So plus 16 all over 8. So that's x equals 2 plus or minus the square root of 20 over 8. Now, I can't take the square root of 20 for a rational number. It's not a perfect square, so, but maybe we can simplify it. 5 times 4. 4 is 2 and 2. So I got a pair of 2. So I can make this 2 plus or minus 1, 2 comes out, root 5 all over 8. And remember I said you have to be able to divide this, this, and this all by the same amount. I can divide them all by 2. So 1 plus or minus 1 root 5 all over 4. And so those are our two answers. 1 plus the square root of 5 over 4 and 1 minus the square root of 5 over 4. All right, let's try the next one. Hopefully you did okay on that one. So this is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 8 plus or minus the square root of 64 minus 28 all over 2. So 64 minus 28 is 36. So that is a perfect square. So this is where we're going to split it up. The square root of 36 is 6. So we have negative 8 plus 6 over 2 and negative 8 minus 6 over 2. So that becomes a negative 2 over 2, which is a negative 1. And that becomes a negative 14 over 2, which is a negative 7. So those are our solutions, negative 1 and negative 7. All right, letter C. Okay, once again, we are practicing using the quadratic formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. So negative b would be 2 plus or minus the square root of negative 2 squared minus 4 times 3 times 2 for 4ac all over 2 times 3. Okay, that's 4. Negative 2 squared is 4 minus, looks like 24 all over 6. but that's going to give me a negative number in the radical, and that's not okay. That's no real roots, no real solutions. All right, so let's talk problem-solving strategy. If you can factor a quadratic, you should factor it because it's less steps, less work, and you're much less likely to make a little arithmetic mistake. There's just a lot of arithmetic that goes in the quadratic formula for something that could be as simple as x plus 1, x minus 2. So always look to factor. And remember, factoring requires you have a set equal to 0. Well, so does the quadratic formula. If you can't factor it, maybe you can use square roots. That would be if there's no x term. And that's also pretty easy. Can't factor it, can't use square roots. All you can do is quadratic formula. You could use completing the square, which quadratic formula is, but quite often completing the square can get kind of yucky. So you usually just want to go with the quadratic formula. So that being said, please give practice 6.2 a shot. You have A, B, C, D, and E. All right, let's see how you did. So first step, I'm going to set this equal to 0. I get 6x squared plus x minus 1 equals 0 when I move everything over. This looks factoral to me because if I take this first term 6 times a negative 1, I get negative 6. And I can think of numbers that multiply to 6, and since it's negative, subtract to the 1 in the middle. So I'm going to do it like this. 3x and 2x. I'll do a plus 1 and a minus 1. So I get a positive 3x minus 2x is x. Then I'll set each factor equal to 0, which gives me 3x equals 1. So that's x equals 1/3. 2x equals negative 1, and x equals negative 1/2. So I definitely think factoring is easier in that one. If you did not factor, though, you should get the same answers that I get. I could certainly test that with the quadratic formula, and I think I'll do that right quick for those of you that chose to do that. So that would be x equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2 times 6 as well. Well, that's going to be 1 plus 24. That's 1 plus 24 is 25. So I have a negative 1 plus the square root of 25 is 5 over 12, and a negative 1 minus, because it's plus or minus, the square root over 12. So that becomes 4 over 12, which reduces to 1/3. That becomes a negative 6 over 12, which reduces to a negative 1/2. And that's how that would work there. All right, let's take a look at the next one. I have x squared plus 8x plus 4. So there's nothing that multiplies to 4 and adds to 8. So I have to use the quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Eight squared is 64, so I'm looking at 64 minus 16 all over 2. So let's see here. What is 64 minus 16? I think it's 48. And 48 is not a perfect square, but I think we can simplify it. That's 4 times 12, which is 3 times 4, which is 2 times 2, and 2 times 2. So I got a pair of 2's and another pair of 2's and 1 3 left over. So I bring out 2 2's and it becomes a 4 on the outside. So negative 8 plus or minus 4 root 3 all over 2. So I can then divide that number and that number and that number. Only if I can divide all three. Remember, you never touch this number inside the radical with the number outside of it. Does not work. So that becomes a negative 4 plus or minus 2 root 3 over 1. So our two solutions are negative 4 plus 2 root 3 and negative 4 minus 2 root 3. All right, letter C. Well, it's not factorable. 9x squared is a perfect square, but 2 is not. Remember, we have a perfect square, difference of two squares, excuse me. When that's a perfect square, minus another one. But because there's no x term, let's use square roots. So move the 2 to the other side, divide both sides by 9, and then take the square root of each side. We need the plus or minus when we take square root, though. And remember, we take the square root of a fraction by square rooting the top, which I can't square root 2, so it's just 2, over the square root of 9, which is 3. So I get positive square root of 2 over 3 and negative the square root of 2 over 3. And be careful to make sure it's clear that the over 3 is not inside the radical. All right, this next one looks very suspicious to me because that looks like a perfect square. That's a perfect square. This might be a perfect square trinomial. The perfect square trinomial pattern is a squared plus 2ab plus b squared. So that factors is a plus b squared. If that's a minus, then there'd be a minus right there. So we need to look. My a would have to be 2x, the square root of that. My b would have to be 1. If I multiply the two together, is this double that? Yeah, this is double 2 times 1. So it must be a perfect square trinomial. Take the square root of that, 2x, take the square root of that, which is a 1, and take the sign in the middle. All right, so you can see I only have one factor to set equal to 0, and I get 2x equals 1, so x equals 1/2. For those of you that tried to use the quadratic formula, something kind of interesting happens. You're going to get a 0 underneath the radical. Let's take a look at that. X equals opposite b plus or minus the square root. B squared is going to be 16 minus 4 times a times 1 all over 2 times 4 is 8. So 4 plus or minus the square root of 16 minus 16 is 0. And 0 is a number that you can square root. It's 0, but the thing about it is we have 4 plus 0 over 8 now, and 4 minus 0 over 8 as our two answers, which really is just the same thing, 4 over 8, or 1/2. All right, let's take a look at this last one. We have x squared equals 5x plus 14. We're going to set it equal to 0. And this one is factorable as well. I can factor it as x minus 7. And x plus 2. So we have x equals 7 and negative 2. Let's talk about our exit tickets. I think this one's worthwhile for sure. We're going to name 4 different ways to solve a quadratic. And which can you always use? Well, we can always use completing the square. It's just not always pretty. We can always use quadratic formula. But we can sometimes factor, and we can sometimes use square roots. So in order to use factoring, it has to be factorable. In order to use square roots, we have to have no x term. And that's it. What I'd like to do now, though, is I'd like to go over a proof of the quadratic formula for those of you that are interested. I'm not going to require this in class, so if you're watching at home and you're not interested, you can turn it off, but hopefully you don't, and we can go through this together. So let's say we have the equation ax squared plus bx plus c equals 0. And it's not factorable because I don't know what a, b, and c are. So again, I don't have a formula. We're about to derive it. So the only thing I can do is use completing the square. And by solving this equation, without putting in numbers for a, b, and c, I'm going to go to a formula that will solve any of them. So first step with completing the square is to move the c over to the other side. Then we can't complete the square with the number in front of the x squared, so I'm going to divide through by a. And I get x squared plus b over ax equals negative c over a. So I just divided through by a. Now, if you'll recall from the completing the square, we're going to take half of this number here, square it, and add it to both sides. That's the completing of the square. So we're going to take half of b over a, which means b over a over 2, which ends up being b over 2a. Just double the denominator, but we're going to square it. And I'm going to add that to both sides. And just for convention's sake, I'm going to put the b over 2a squared in front here. All right, we know what this left-hand side is. It's a perfect square trinomial. You can see that this number, the square root of this is half of that. So you take the square root of this, take the square root of that, and it should be half of that. X plus b over 2a squared. That's how that factors. The right-hand side here is b squared minus 4a squared if I square the top and square the bottom. But I want a common denominator, so I'm going to multiply by 4a on top and bottom of this fraction. So I get minus 4ac if I put it in alphabetical order with a constant in front. And now I have 4a squared. By doing that, I get a common denominator, which allows me to combine the fractions, which is just convention. That's just conventionally the way it's written. B squared minus 4ac all over 4a squared. We'll take the square root of both sides, but if you take the square root of both sides, you need plus or minus. So I'll take the plus or minus square root, and that's going to give me plus or minus the square root of square root at the top. This is the square root of b squared minus 4ac. But you notice something about the bottom. The bottom's a perfect square, so when I take its square root, it's just 2a. All right, lastly, I'm going to move this over to the other side, giving me x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. But I don't want to leave it that way. I want to make it look nice and pretty. So I'm just going to make the plus or minus to the top. So it's negative b plus or minus the square root of b squared minus 4ac with a common denominator of 2a. And there you have it. All right, until I see you again, take care.